In this presentation, we're going to be looking at Maya's powerful DirectX 11 integration. When working in DirectX 11, you can create and edit high-quality assets and images in less time using Maya's DX11 shader. The DX11 shader offers real-time, centralized, easy-to-control shader effects. Things like crack-free tessellation, vector displacement maps, translucence, and reflections are all handled. The DX11 shader is built on Maya's API, and it exposes DirectX 11 natively to Maya with high-level shader language support. Included in the DX11 shader plugin is the Maya Uber shader, an HLSL shader that provides many of the common effects seen in next-gen gaming directly inside of Maya's viewport. Things like vector displacement maps, real-time shadows, and blurry reflections are now available through this Uber shader, and we're going to be using it to generate two different effects in our scene. We're going to make a nice skin shader for our monster, as well as a nice metal material on the muffler. So one of the things that's really great about the DX11 shader inside of Maya is it automatically handles the light binding for you. So what that means is if you have HLSL shaders, they'll automatically get hooked into the native Maya workflow and experience. So if I do something like hit my 6 key, which is my hotkey to go to my default lighting, which is just attached to my camera, you can see that this DX11 shader that's attached to that monster respects the same calls as the native Maya shaders. I can even go as far as to maybe select a light and say shading, use selected lights. Now if I start to translate that light around, you can see that the native Maya materials in the background as well as the DX11 material are all behaving and respecting the lighting selections that we have or the light binding that we have set up. So obviously if I hit my 7 key, which is my hotkey to go back and view my hardware lighting, the DX11 shader respects that command just like the native Maya shaders. So what we want to do is we want to start to really fine-tune the look and feel of the skin by simply turning on and off some of the different attributes on this Maya Uber shader. So the first thing that we're going to do is we're going to give it a little bit of ambient light, kind of pop that up a little bit, and that's just going to be just a skylight on the top of it to kind of brighten them slightly. The next thing that we want to do is we want to start to break up the overall look of the skin. Right now it's very smooth looking, so we're going to go ahead and add a normal map, which is going to kind of make the skin look a little bit better. And once we turn this normal map on, you can start to see that we have that kind of detail sort of coming across here, but we're not really getting any displacement from that. So what we're going to do now is scroll down to our tessellation and displacement attributes, and we're going to enable this displacement map. This is a tangent-based displacement map coming out of Mudbox, so the fact that it's a tangent map allows me to capture things like undercut. So if I start to increase the value here, you can really start to see how it's not just pushing out based on the normal, it's actually using that vector to sort of give me that undercut underneath that little guy's belly. It's worth mentioning that the tessellation is actually happening on the GPU. You can see that our hardware tessellation mode is set to on. We could jump over to the wireframe. You can start to see the density of our original mesh, which is displayed as the highlighted mesh, versus the displaced mesh, which is the mesh that's getting displaced and tessellated on the GPU. Let's go ahead and jump back into our shader here and get out of that wireframe mode. So now that we've got some displacement and some normal on our character, he's starting to look a little bit better, but the lighting model's still extremely harsh. So what we want to do is we want to start to fine-tune this a bit by changing the diffuse model from the basic Lambert model to one that has a little bit of a blend value that allows me to really start to dial in sort of the transition effect of what's in shadow versus what's being directly illuminated. So if we turn this blend value down, we're kind of back to the Lambert model. And as I start to increase this blend, look right here where the area that's get directly illuminated versus the area that's in shadow, and you'll notice that it basically starts to soften out really nicely by giving it that little blend value. So it really starts to make the skin look a little bit more realistic. So the next thing that we want to talk about is the ability to have image-based lighting affect our characters. Diffuse model. So if we go ahead and we turn on the image-based lighting, I've got piped into that just an HDR file, and if we kind of overdrive the value of this image-based lighting here, you can really get a sense of what that's doing. So right now you can see sort of the horizon line where that sun's kind of coming in there. It's a little bit harsh because it's using this full resolution of that environment map, and we'll turn that back down to a value of 1, so it's not quite so hard. And what I'm going to do is I'm just going to start to blur this out. So as I start to soften the effect or blur out that image-based lighting map, you'll see that it really starts to give us a sort of nice contribution from the environment to our character's lighting model. And we can turn this down to maybe something like 0.5. And now that we've got some image-based lighting bouncing some indirect light into that character, we can turn down that ambient a little bit. So now that we've got our normals happening, our displacement happening, and our diffuse model looking good, we want to start to kind of refine the specularity on this character. So we're going to go down to our specular model, and right now what we're using is just a kind of a basic blend model, so it's really not that sophisticated at all, and it doesn't really look like skin. So what we're going to do is we're going to go ahead and turn this from a blend specular model over to something that's a little bit better for skin. As soon as I do that and overdrive this here, you can start to see that we're getting this kind of nice angelic glow on the character. And as I spin this guy around and get some backlighting coming across him, he's going to get this sort of really nice kind of pop on the glancing angle. We can further break that up with a little specularity map. That starts to really look much better than it did when we started. So the next thing that we want to do is finish this character off by adding a little bit of subsurface scatter into him, a little bit of translucence. So we'll kind of scroll down here to the translucence tab, and we'll turn this on. So as soon as I turn that on, I've kind of got it overdrive, and it, you know, it really kind of looks like a jelly bean. So if we start to increase the distortion on this, you can see that that guy sort of kind of breaks up a little bit as it sort of you know, it gets hot and it still starts to break down. And we can further refine this by adding in a translucence mask. So I'm going to overdrive that one more time. Let's get that power kind of drop down a little bit here, and we'll turn on the translucence mask. And what the translucence mask is, it's just a luminosity value that I've painted. So I've got some bright colors sort of on his ears and some brighter spots going down his spines, and then the rest of him I kind of almost black it out, so that that translucence mask is really going to let just things like the ears, when he gets backlit, sort of glow. And if I turn on and off the translucence, you can see the effect of, you know, the kind of the little spines on the back, the little spines kind of coming across here, and his ear is still getting that nice translucence model added into it. So to finish this guy off, I'm just going to jump over to a preset that's done. It's going to brighten it up maybe just a little bit there, and that's what we went from you know, a character that was relatively simple in its shader model to something that had a lot of the bells and whistles thrown at it, and it really starts to look extremely realistic and pretty good. So let's go ahead and look at the next shader, which we want to work with, which is going to be this kind of muffler down here, and we want to get a brushed metal effect happening. So let's just rewind our animation on our character, sort of get him away so that he's not shadowing our little piece of geometry here. And we'll dive in on this guy and start to refine this. So I've already got a lot of the stuff sort of piped into here, just like with the monster. And what we're going to do is we're just going to kind of walk through this and start turning on these different effects and talking about what they're going to do. So the Lambert model we're going to be using for this is fine right now. That's totally cool. We don't need to worry about that. But what we do want to do is we want to, and you can see I have that image-based lighting probe still kind of tying into this. We really want to work with the reflections and the specularity for this piece of geometry. So let's dive into the reflection section first. So let's kind of come down here into the reflect, and we'll turn on our reflection. So this is just using, again, a simple lat long map. And if we increase the value of this reflection, as I start to increase the value of the reflection, you can see that it automatically starts to drop the diffuse. So if we get an intensity value of 1, the diffuse model's all gone and it's fully reflective. Obviously, we have the ability to blur those reflections out. So if I start to increase the blur slider, it really starts to soften those reflections. And this looks pretty cool. We can do some Fresnel effects, so sort of based on the glancing angle, or the reflections get brighter, or if the glancing angle is not as abrupt, or is it going to go more to a diffuse model. For this example, we're going to leave the kind of the Fresnel stuff turned off, because really what we want to look at is fine-tuning the specularity model. So to do the specularity model, what we're going to do is we're going to be, instead of using this just a simple blend, and I've got a little spec map in there that we can break that up with, we're going to go ahead and switch this over to be an anisotropic model. So this is going to give this ability to get this nice brushed metal effect. And essentially what it does is it puts micro kind of grooves down the object that catch the light in a certain way. So if those grooves are going in a given direction, you're going to get nice long streaky highlights in that direction. So if we turn on the anisotropic model, you can see that we get that nice long streaky highlight kind of coming across there. Pretty straightforward. We can kind of tone that down a little bit. One of the things that's kind of cool about the anisotropic shader inside of Maya is we have the ability to use a tangent map, kind of a flow map. So you can use color to define the direction of those micro grooves or micro scratches. And you can see that I have one right here that we've already kind of saved out. So what this is it's just got red for one direction and blue for another direction. So between the red and the blue value, it defines which direction the specularity goes. And then I've got a little bit of noise sort of kind of piped into that guy. And we're going to use that to really, again, fine-tune the look and feel of what this shader looks like. So as soon as we turn on use direction map, you can see that we get that kind of swirling pattern sort of coming across this. So let's start to kind of dial this back a little bit here. We can turn down the amount. We can adjust the overall contribution of that angle. If we go to the minus side, it starts to kind of flip around and look a little bit different. So one of the things that's also really interesting about this is a lot of these attributes have the ability to kind of get enabled or disabled based on luminosity values in an alpha channel. So we can mix between the blend model and the anisotropic model based on the alpha of the specular map. So if we turn that on, or I'm sorry, the alpha of the anisotropic map. So if we turn that guy on, you can see that, let's just get this value sort of going positive, and we'll get that sort of nice harsh bright line there. You can see we get that really nice kind of anastrophic scratches happening there, but where that little spot was, they sort of fall out, and that's because, again, we're just feeding this map into that flow map. Has this this flow map in the alpha channel has this same spec map kind of piped into it, so it really starts to break up that anastrophic model. Again, we can use holdouts for things like the reflection. So if I go in here and turn on a reflection map, that sort of breaks it down a little bit. So we'll just kind of dial through a couple different presets that I have set up for this guy. So I've got one that's kind of dark and moody. So again, just kind of changing different attributes on that to kind of come up with that look. And then I've got another one that's kind of bright and shiny, a little brighter, a little shinier. And on this one, what we're doing is we're using a negative value on the anisotropic angle. So if you look at the map that's piped into this guy, you can see that the roughness has got kind of a little bit of a negative value on it. So let's go ahead and just frame up our shot here, and we'll play this back one last time. And that is an example of a few of the different types of effects that you can achieve using Maya's DX11 integration. Obviously, it's really nice to be able to animate characters and see those things like the displacement maps and the vector displacement maps kind of covering that across this character and getting this really cool effect of these sort of next-gen shaders directly inside of Maya's native viewport.